Good evening all. Today we shall see the hydroelectric power plant in the first module. So hydroelectric power plant is a method used for bulk electricity generation. Energy from hydroelectric power plant is renewable in nature. It is powered by water cycle. Actually, the potential energy of water kept at a particular height is converted initially to kinetic energy by driving it from the higher head to lower head. Then, when it is subjected on a turbine, this kinetic energy is converted to mechanical energy. When the turbine is coupled with an electric generator, the mechanical energy is converted to electrical energy by means of the electrical generator. So, the potential energy of water is ultimately converted to electrical energy. This is what is happening in a hydroelectric power plant. Here you can see the approximate working animation of a hydroelectric power plant. Here you can see a reservoir where water is being kept. Then a dam is constructed in order to create this reservoir. Then water from the reservoir is going through a narrow pipe called penstock pipe to the powerhouse, where the turbine is being kept. When water is subjected on this turbine, it gets rotated and mechanical energy is being produced. When the turbine rotates, the mechanical energy produced by it is supplied to a generator by coupling the turbine with the electric generator. Hence, the generator produces electricity as per Faraday's law of electromagnetic induction. Water after use from the turbine goes to the tail race by means of a tube called draft tube. This is the approximate working of a hydroelectric power plant in brief. Now we shall see the site selection for hydroelectric power plant. So first point is the availability of water. Water should be available because the fuel used here is water. Then transportation facility. In order to construct the power plant as well as to operate it, we need transportation facility. Then head of water. Water should be available at a particular height. So head of water is also important point while we are selecting the site for a hydroelectric power plant. Then there should be storage facility for water. There should be some means for arranging a reservoir. Then cost and nature of the site. Cost should be minimum so that we can, in the case of hydroelectric power plant, we need large amount of area. Area requirement is there and the land has to be purchased. So, it involves some cost, capital investment. So, the cost should be minimum. The nature of site should be free from natural calamities. Then environmental factors. The construction of the power plant should not disturb the surrounding environment. Then the topography of the area should be suitable for the construction of the power plant. These are the points to be considered for site selection of a hydroelectric power plant. This is the diagram we have to study as block diagram of this hydroelectric power plant. Here you can see reservoir. This is being arranged by means of constructing a dam across a river. So water is being stored inside the reservoir. Then according to the demand, water is conveyed to the powerhouse by means of penstock pipe. Then there is a trash rack. This prevents the objects getting entry into the narrow pipe and producing block in the penstock pipe. So water from the reservoir that is kept at a particular height, head of water, high head of water is conveyed to powerhouse which is kept comparatively at a lower head. Then water is conveyed from reservoir to powerhouse by means of penstock pipe. Then in the powerhouse, we are having the turbine as well as electric generator. So when the water is in the reservoir, water has got some potential energy. When it is driven from this higher head to lower head, water requires kinetic energy. Then when the water is subjected on the turbine, it is converted to mechanical energy, and when this mechanical energy is input to the electric generator, generator converts mechanical energy to electrical energy. Water after use from the turbine goes to tail race by means of a pipe called drum tube. Then there is a surge tank. Surge tank is constructed near to the powerhouse. This is constructed in order to avoid the inertial forces developed inside the penstock pipe due to sudden withdrawal as well as increase in demand of electricity. So this is the block diagram, and next we shall see the various parts of the power plant in detail. A hydroelectric power plant is actually employed for electricity generation. Then it can also be used for irrigation as well as flood control. Then the main features of hydroelectric power plant are its running cost is very low because the fuel is free in this case. Water is free. There is no transportation cost associated. So the running cost is low for hydroelectric power plant. It is reliable also. It can be turned on as well as off quickly. So it can react to changes in demands in a rapid way. Then it has got greater life. In this case, there is no waste disposal problem like ash disposal, then flue gases, etc. are not being generated in this case. Then highly efficient over a considerable range of load. Then it can be used as a base load as well as peak load plant. It can be used to drive for 24 hours, or since it can be put on and off quickly, it can be used to meet the peak load demand also. Then essential parts are reservoir. Reservoir is the basic requirement of any hydroelectric power plant. Water stored in the reservoir is used to run the turbine to produce electric power. A reservoir can be natural or artificial. Artificial reservoirs are formed by constructing a dam across a river. Then a dam is a structure built at a suitable location across the river whose primary function is to provide head of water. Economy and safety are the basic requirements of a dam. The dam should be capable of resisting the pressure of water and silt. So a dam is constructed across a river in order to form a reservoir beyond that. And trash rack. It prevents the debris from getting entry into the penstock pipe from the dam. It is made of steel bars and placed across the intake of penstock pipe. Then it has to be cleaned regularly. Manual or mechanical cleaning is used. And penstock. In order to convey water from the reservoir to the powerhouse, we are using the penstock pipe. It can be made of steel or RCC or wooden type. It can be closed type as well as open type. If it is open type, it is economical, it is cheap, but if there is a landslide or snowfall, some blocks may be produced inside the penstock pipe if it is an open type. Then closed type penstock pipes are costly. And tail race. Water after work in the turbine goes to the tail race. Draft tube connects the turbine exit water to tail race. It is a metallic pipe or a concrete tunnel. So water from the powerhouse after use goes to the tail race by means of draft tube. Here you can see the penstock pipe, then powerhouse. Then water after use goes to the tail race. And powerhouse and equipments. The powerhouse includes turbines, then electric generators, governors, gate valve, flow measuring equipment, transformers, switchboards, etc. Turbines converts kinetic energy of the water coming to the powerhouse to mechanical energy. This mechanical energy is converted to electrical energy by means of generators. Governor controls the intake of water and controls the speed of the turbine according to load demand. Then gate valve allows the entry of water into the penstock pipe. Then flow measuring equipments measures the speed of water coming. Then transformers are used to step up the electricity voltage being generated in the generators. Then switchboards for proper controlling. Then surge tank. Surge tank is a storage reservoir fitted to the penstock pipe at the point near to the turbine, that is powerhouse. It is provided to overcome the inertial forces in the supply pipe during the fall of load and to act as a reservoir of water during increase of load. We know that the penstock pipes are very long, sometimes some kilometers long. So water is conveyed from the reservoir to the powerhouse by means of penstock pipe. Whenever there is a sudden rejection of load, the valve will be closed and the water in the penstock pipe will be returned back. But at that time, some inertial forces will be produced inside the penstock pipe due to sudden withdrawal of the load. So due to this, the water has to be conveyed to or bypassed to some other reservoir. So surge tank is such a reservoir where excess water will be stored, and whenever there is a sudden demand, water from the surge tank can be used to meet the sudden requirements. This is the purpose of surge tank. Surge tank controls water when the load on the turbine changes. So this is a penstock pipe in which a surge tank is being constructed. Spillway. It controls the water level of the dam. Whenever the water rises above the maximum water level of the dam, water has to be sent out. So, in order to send this water out from the reservoir, we are having spillways. Spillways are provided with shutters. So, whenever we have to send out the water, the shutters will be opened and water will be sent out of the reservoir. It prevents the overflow of the dam. Then working, in hydroelectric power plant, the potential energy of water due to its high location, high head, is converted to electricity. The total power generation capacity of the hydroelectric power plants depend on the head of water and volume of water flowing towards the water turbine. More the head of water, more is the power produced in the hydroelectric power plant. To obtain the high head of water, reservoir of water should be as high as possible and power generation unit should be as low as possible. The maximum height of the reservoir of water is fixed by natural factors like height of river bed, the amount of water and other environmental factors. The total flow rate of water through the penstock pipe can be adjusted as per the requirements. If more power is to be generated, more water can be allowed to flow through it. The turbines convert the kinetic energy of flowing water to mechanical energy when water coming to the penstock pipe is allowed to fall on it. Mechanical energy produced by the turbine is converted to electrical energy using a generator. Inside the generator, electricity is generated according to Faraday's law of electromagnetic induction.